Hello, hello. So we have very good news. We do get to do our original lab. Now, I will say this is not going to be as easy for you guys as it is for the in-person students. I try my best, but you are going to be limited by the photos because there isn't a good way to get every single angle that you are going to need. But also, forensic anthropology is a very hands-on practice. There's just really no way to kind of supplement that in a digital form. Because of this, though, I don't expect you guys to have perfect answers for things, perfect estimation ranges, anything like that. That'd be kind of insane anyway, since this is something that's new to all of you. I'm sure most of you guys don't really have any background in forensic anthropology, aside maybe from the TV show Bones. So that is what we're going to do today. We're going to go through a lecture talking about what forensic anthropology is, what forensic anthropologists do, some of the methods that you are going to be using for your case report, as well as your case report and what I am expecting out of it. So let's get started. What even is forensic anthropology? It's really just a very specific subfield of biological anthropology, but what makes it different is that you are applying skeletal analysis and techniques in the effort to solve criminal cases. Criminal cases is a little bit of a misnomer. Sometimes this will take the form of criminal cases. More often than not, though, it's going to take the form of just modern human remain cases. So cold cases, sometimes it'll be like mass graves from historical events in recent times, different wars and stuff like that. It isn't always going to be something where there is a nefarious story behind it. But what it is going to be focusing on is modern human remains. Generally, this means anything within the last 50 years. However, we have such a backlog of cold cases, and this is everywhere in the US, unfortunately. We also are starting to improve a lot of techniques that can help us get through a lot of those cases quicker. So DNA testing, especially, is actually a relatively new technique. It has not been around for that long. It's only really been an option whenever the Genome Project was completed, which I want to say was in the mid-2000s. I don't remember exactly off the top of my head. Now, forensic anthropologists will often work with law enforcement agencies, although quite a few of them, rather than working directly for government agencies or, some kind of law enforcement crime lab, although plenty of them do work in those positions as well. A lot of times forensic anthropologists will actually be working at a university. Now, what they do is they're going to work with law enforcement agencies to identify an individual's remains, to help understand the circumstances surrounding their death, and then sometimes to solve crime. So occasionally you will get a case where it is recent enough that they are trying to prosecute an individual for committing the crime against the unidentified remains. And then in those instances, a forensic anthropologist that worked on the case might be asked to come in and testify. But that's going to be a pretty case-by-case basis. It's also going to depend on the forensic anthropologist, because especially if it is a forensic anthropologist that is working at a university, that is really working with law enforcement to allow students to kind of get that opportunity and that experience, they aren't going to be working on cases that have a high chance of there being any kind of legal action involved. So the chances of you actually being called in to testify are pretty small. especially as I mentioned before with DNA testing really becoming a thing, that has limited a lot of what is necessary for a forensic anthropologist to actually come in and testify about. That doesn't mean that it still doesn't ever happen, of course. But my favorite part of forensic anthropology is the real world application and impact that it has on individuals. One, just providing the individual that has passed their identity back is a really good feeling. But also, especially if it is a more recent case, that individual might have family members that are still alive, that have been wondering what happened to this person for years, for decades. You know, this is somebody's brother, sister, child, mom, dad, cousin, uncle, aunt, whatever. Sometimes it's just a really good friend. But in my experience, working in undergrad to actually help solve cases, there were a couple of solves where it was really, really impactful and really, really emotional. You know, some of the families were so grateful to finally have these answers that they actually invited those of us that worked on these cases to the funerals that they were holding after they finally got these remains of their loved one back. Some of them invited us out for dinners just to be able to, you know, express their gratitude at this question that's been hanging over their heads finally being answered. So it has a very real world impact. On to a happier, or I guess at least less sad note. What can we actually determine from skeletal remains? A lot. And the first thing that we need to kind of determine whenever remains are brought to us is, are they even human? Now, every forensic anthropologist is going to be able to tell pretty quickly, just by looking at the bones at a glance even, if something is human or not, because human bones have very specific characteristics, very specific textures, and very specific morphology. Now, this might be a little bit harder if you're only getting like tiny fragments of bone, although generally you can still kind of tell if it is human or not because of the texture of them and how dense or how thick they are. It might sound kind of goofy that someone would mistake this, but it's actually not uncommon to have civilians bring bones in that they have found on their property or, you know, doing whatever. And they want to check and see, like, hey, I think these might be human. Can you please check? Oftentimes they will come to a university if there is one in their town or in their city, just because they tend, you know, professors, I think, tend to be a little bit more open to interacting with the public than the police force might be. And honestly, a lot of the police force is not going to be trained to actually determine this. And it might sound kind of goofy, but I'm going to show you an example in the next slide of just how easy it can be to confuse human bones with animal bones if you don't have that experience. Now, I will say, however, 9.9 out of 10 times when someone brings bones in thinking that they're human, they're not. They're animal bones. Typically, it's going to be native mammals in the area. We get a lot of deer bones. We get a lot of cattle bones. Sometimes people bring in like bird bones thinking that maybe these belong to like a human infant. It almost never is. Now, once we've determined that the remains are human, we are going to have to do an inventory. These can take all kinds of forms. I mean, the general structure of them is going to stay the same, but they are going to differ depending on where you are at, who you are working for, and what law enforcement is wanting out of this. So maybe they have some information about this already, especially if it's a cold case that they have processed. So they might not need a super detailed list. They might just be wanting you to kind of double check that theirs is correct. Regardless, we always do an inventory. After we do that, we are then going to determine MNI. Now, this stands for minimum number of individuals. You might be asking why we don't try and determine the maximum number of individuals. And the reason that we don't is it's about as close to impossible as you can get. You could do DNA testing on every single bone in a set of remains that you get, or sets of remains that you get. Sometimes they're jumbled together. But that's very impractical, and nobody is doing that. One, DNA testing is not cheap. And two, the process for any kind of testing in that manner, whether it is DNA testing, whether it is radiocarbon dating, whether it's strontium testing or nitrogen testing or anything else, it is inherently destructive. It is going to destroy the remains. We want to minimize that. Now, it's always destructive. You know, there's constantly improvements being made with technology and the tools that are used so that we can try and take less and less bone. But you have to slice into the bone to get a sample to actually test. We don't want to do that to every single bone. So instead, we will determine the MNI. We are going to do this by looking at our inventory sheet, and you might see that, well, when I did the inventory, I see that I had 2 left femurs. One person does not have 2 left femurs. So at that point, you can assume that the MNI is 2. Maybe you continue going through the inventory and then you see that, oh, I had 3 skulls in the mix. Well, you can determine that there are at least 3 individuals. If we did the maximum, it would just be very inaccurate because technically every single bone in that set of remains could be from a different person. We don't know. Once we have determined that, we are going to start doing our different estimation types. Now, remember, these are estimations. They are not determinations. Typically, you are going to want to start with age estimation, and this is because all of these other estimation types are kind of dependent on you knowing the age. You can flip-flop sex and age, and it's mostly fine because these other estimation types also kind of require you to know sex. But really what's important is that age and sex estimations are the first 2 estimation types that you are completing. Now, whenever you are doing age estimation, you do not want to give an exact number. You want to give a range. If you give a very exact number, for one, you're going to be wrong. Almost certainly. There is not a forensic anthropologist alive that can look at a set of remains, measure a set of remains, anything, and then tell you that this person is this precise number, that they are exactly 47 years old. That's not how that works. There's so much variation in humans that all of the methods that we use to determine age, aside from like DNA testing, are going to give you a range. They'll give you a mean age, but it's not exact because humans grow at very different rates. Things like your diet, your general health, your genetic makeup, what you drink, the minerals that are in your water from the area that you live in, all of those can impact what the skeleton looks like, as well as how it develops. Then we are going to do sex estimation. Keep in mind, sex estimation is talking about biological sex. It is not based off of any kind of phenotype that you can outwardly see. It is purely based off of biological reproductive strategies. Now, what I mean by this is that it is based on your actual internal gametes. So whether you produce sperm or whether you produce eggs. This is true of all mammals. Now, sex estimation is not gender estimation. Gender is a social construct. You cannot estimate gender from a set of remains. Now, you can also estimate stature. However, this is going to be something that you have to be able to measure. And typically, it's not going to be very accurate unless you have a long bone to measure, so something in your arm or your legs. We will not be doing this for your lab because there is no possible way for me to provide you the physical tools that you would need to measure bones that you can't physically see. We are also not going to do group affiliation in this lab. Stature and group affiliation estimations are also a little bit more of an advanced kind of methodology and technique. Generally, it's not something that you would learn in an intro course anyway. Now, group affiliation is also sometimes called ancestry. It's also sometimes called race. It's got a lot of different monikers in an effort to make it seem better, more inclusive. At the end of the day, it just means race. Because every methodology that we have for group affiliation is based on outward characteristics that we kind of assign to certain racial groups. And the racial groups that we include for a methodology are very broad. It is not getting specific about where you live. It's literally just whether this is a white person, whether this is a black person, whether this person is some kind of Spanish origin, and then whether they're Asian. So, there is such a wide and diverse range of skin tones, of physical traits. It's not a great technique, and it's not very accurate, and it's not very useful. Especially because none of the techniques that we have are very good for determining somebody that has mixed ancestry. And especially in the US, this is very common. And the methodology that we use just can't really deal with that. So it is losing popularity, especially in more recent generations. But I mean, this has been happening for a while, to the point that not all forensic anthropologists will just automatically include group affiliation in their reports unless law enforcement agencies specifically ask them for it. Likewise, the data that we have really does suggest that including group affiliation doesn't really improve identification rates. It doesn't actually help that much with matching this unidentified person to a missing person. We can also determine time since death. This is going to be based off of decomposition rates. However, oftentimes if a forensic anthropologist is being called in, you might not have any decomposition to judge. Oftentimes it is going to be remains that are well already decomposed, and so there is nothing to judge. It's just bone. We're also going to talk about trauma. So there are 3 types of trauma that can occur on bone. Or just on the body in general. The first is antemortem trauma. This means before death. We can tell if something is antemortem because you can actually see where the bone has began to heal. So you will see that bone remodeling, and it's a very obvious look. And that lets us know that this person had a chance to heal. So obviously this could not be the cause of their death. It could not be some kind of circumstance after the death. So it really doesn't play much of a part in helping us decide who this person might be, unless it is something like something more pathological in nature. So maybe this person has had like a hip replacement or a knee replacement. You can see where that has kind of healed around it. And that might help if you can get a hold of any medical records to kind of double check and see or narrow down your list of missing persons. The second type of trauma is perimortem trauma. This is going to occur at or near the time of death. So at or very shortly after the death. The very last type is postmortem. This is going to be after the death. The difference between the two when you're looking at the skeleton can be a little bit harder to tell, but definitely not impossible. Because perimortem injuries are occurring on bones that haven't began that decomposition process yet. So they're still wet. They're still inside the body. They're still pretty wet. They're very saturated at that point, which means that the bone is going to have a little bit more bend to it before it breaks or is crushed or any other kind of injury that might damage it. So when it does break, it's going to be a cleaner break in the idea that it's not going to have splintered edges. It's very wet, so it's going to be very clean. You might have a kind of jagged break where it didn't break perfectly in half, but that kind of jagged, sharp edge is going to be clean. It isn't going to be rough on the edges, and it's going to fit back together with the other bone pretty well. Now, you might be kind of wondering, well, how can something occur shortly after the time of death if it's not the cause of death or the manner of death? This is not always going to be something nefarious. It might be. Now, it might be that somebody, was attacked and the attacker kept going after the person died. But a lot of times this is actually going to take the form of like animal scavenging. Or it could even be that, maybe this person fell off a cliff while hiking, and while they are passing away, a landslide or some other kind of natural event occurs and the body gets damaged in that. Post-mortem breaks and injuries, however, these are occurring on bone that has already started to decompose, on a body that has already started to decompose. So the bone is going to be dried out for the most part. So when it does break, it's going to be fibrous-y. It's going to try and stick together more because those dry fibers of the bone matrix want to stay together. There is no liquid in them to help them, hydrate and actually form a strong bond. They're not going to be a clean break because of that. They're going to be trying to grab onto each other as much as they can. So where the break is going to be very jagged. It's going to be very rough. It's not necessarily going to be a very clean break. Sometimes if bones are very, very dried out, then it might be a cleaner break, but the edges of the break are still going to give it away that it is post-mortem. And again, this might take the form of somebody passed away hiking or outside and nobody finds their remains. Maybe nobody's really looking for them because they, just assume that they're okay. If bones are out in the sun especially, so if they aren't completely buried, if they are not in perfect conditions, then they are going to get very dry and brittle. The last thing that we might help determine is the manner of death. This is going to be this inclusion of details like, oh, there's a bullet wound on this bone, or there is blunt force trauma to this bone. What we cannot determine is the cause of death. That is a different thing. This is going to be where you are, deciding whether the individual has passed away from a homicide, maybe from a suicide, maybe from an accident. Those kind of aspects have to be determined by a medical doctor, typically in the form of a state coroner. All right, so are the remains even human? You can see here, we've got two different hands. One of them is a bear claw. One of them is a human hand. I'm going to let you take a second to form a guess over which is which in your own head. But you can see here why somebody might easily get confused. If you are not trained to notice the differences, then you're probably not going to. Now, what I want you guys to pay attention in terms of differences is not only the carpals, so your wrist bones, those are a little bit different, especially in size, a little bit different in shape, but also the very distal phalange, so the very tips of the fingers. The bear claw distal phalanges look kind of stumpy, like they aren't quite finished. That is because it's going to be attached to the actual claws of the bear, and they will articulate there. Humans, we have these flat nails on top of our hands, so we don't need them to actually articulate to our skeleton. So there are two main types of observation and data collection to be able to do forensic estimation. The first is morphological traits. These are qualitative, they're a little bit less precise, and they're a little bit more subjective because it's very based on who is looking at the remains. This means that it is subject to more observer error. However, this improves with experience. And generally speaking, this improves with experience to the point that it is actually more accurate than metric analysis. And remember, when you're talking about data, precise and accurate are two different things. Do not confuse the two. They're not interchangeable. But yes, typically this will improve with your experience. Sometimes it will be more accurate. It's what I prefer to do. However, any practicing forensic anthropologist should be doing both techniques to kind of double check their own work and to help bolster their argument for their report. So these morphological traits are going to be traits that you can judge using your senses of sight and touch. Again, this is very difficult for you guys because you just can't do that. Now, this is going to be used for things like age, group affiliation, and sex estimations. It cannot be used for stature. I get a couple students every single semester swearing that it can, especially by the time we get to the quiz. It cannot. It cannot. Now, you can look at a set of remains and, judge based off of just how overall large or small they look, that like this person is tall or this person is short. But you can't actually give a definitive estimation for them being 6'2" or 5'3". Some people might want to argue with that notion because, well, you can line them up and just look at the full, length of them. But the problem is, when you do that, you aren't accounting for everything in between your bones. You're not accounting for the muscles, the tissues, the ligaments, the cartilage, and everything in between that makes up your body, including your height. Now, when we move on to metrics, these are going to be quantitative. They are more precise. They are slightly less subjective because you're measuring something. So, there's less ways to be biased in that way. However, it's not necessarily more accurate. This is because it doesn't matter if it is the same person measuring these traits. You're never going to measure anything the exact same multiple times. This is doubly true because some of the points that we need to measure for it to be useful aren't exact points on the skull or the body. They are relative positions. And because humans are so variable, you're kind of also relying on your experience to be able to, tell you where you were actually needing to measure. Now, there's also the issue too that your measuring device is never going to be calibrated perfectly from every single person that you buy one from. So you might buy tools from the same company, but even the same company is not going to be able to ensure that the way that their tools are calibrated are 100% even across the board. All right, so what are we actually doing when we measure these bones? Well, we're using tools like sliding calipers, spreading calipers, and osteometric boards to do the measuring. And this is going to help us determine things like stature, of course, but also group affiliation and sex estimations. It is not used for age. It's not used for age. The only time that metric traits are ever used for age estimations is when we are discussing subadults, so children. Even then, it is not preferred because there are better methods that are going to be more accurate. You can see some of those here. So for age estimation, especially for subadults, we are going to focus on things like dentition and epiphyseal closures. Dentition is really good for providing an age that you can actually narrow down a little bit more for children. Why? It's a pretty predictable pattern on how your adult teeth are going to come in, and also around what age they are going to come in. It's also pretty predictable when you're going to start getting baby teeth, when you're going to start losing those baby teeth. You can also do a little bit of judgment on this for adults based off of whether or not their wisdom teeth have actually erupted, whether they have actually, started poking through. However, as I mentioned before, not everybody is getting wisdom teeth. This is something that we are slowly losing in the modern era because our diets are so soft now. We just don't need that extra set of teeth coming in later at life. So a lot of people are not developing them. Also, a lot of people get them removed. So there is no guarantee that a skull that you get is going to have wisdom teeth. Even if it does, there is like a rough age that wisdom teeth will typically pop out, but that also varies. Now with epiphyseal closures, that is actually looking at your long bones, so your arms and your legs, and at the tops and the bottoms of them. Now what this is you have a growth plate on top and on bottom of the bone. This is what allows you to get taller as you're growing up. The reason that it isn't just fused, it's not just one solid bone the entire time, is that it would make every growth spurt excruciatingly painful because your bone would essentially either have to rapid fire build on top of itself to create that height that you need as you grow, or it would literally have to like break and then regrow on top. That would be very painful. So thankfully, nature had a little solution for us, and instead we have these growth plates. Now, by the time you're reaching young adult to mid-adulthood, again, this is also going to vary a little bit, all of your epiphyseal plates are going to be closed. They're going to fuse. So at that point, if you see that every single growth plate is fused, then you can assume that that individual is at least a young adult. They're not a subadult. We can also determine age by looking at the skull. through the suture closures. Now you can see here, we've got these squiggly lines all over the outside of the skull. These are sutures, and it is where your skull actually forms and where it starts to become one. You know, we talk about babies having that soft spot in the middle of their head when they're little. That point where three sutures meet, that point A on the coronal suture, that is actually where the soft spot is and where they start to form together after infancy. Now, the reason that you need a soft spot is we would not be able to have, you know, natural birth if babies didn't have that soft spot. Our heads as humans are just way too large, which in some ways is great because it means that we are very intelligent primates, but it's not the easiest when you're the one actually having to give birth to that. Now, when we're looking at these suture closures, we are looking to see how open or closed they are, and we score these on a scale from 0 to 3. 0 means that they are open. You can very clearly see this suture. You can see a very strong dark line in between them. My professors in undergrad used to say that imagine you took the skull and you poured water in it. If the water would come out because the suture has that space between it, then it's open. Then we can also kind of say that the suture is kind of open, or maybe it's starting to fuse. We're going to label that a 1. This stands for minimal closure, and it means that it is less than 50% fused. So it's going to be a tighter suture, especially in some spots, but it isn't going to be totally open, and it's also still going to be relatively visible. By the time we get to number 2, this means significant closure. This is anything that is fused greater than 50%. So at this point, you can definitely see where they are fusing, where they're starting to kind of disappear almost. They're getting very, very tight. There isn't really a divot in between them anymore. It's kind of starting to smooth out to one texture. That is going to be your significant closure. Now, in your reports, you do need to know which of your sutures were minimal closure or significant closure, and you need to include whether or not that is more or less than 50% closed. By the time we get to number 3, this is when a suture is completely obliterated, aka it is completely fused. At this point, you should not really see the suture at all. You won't see the line where it was. Maybe you see a couple of little like pits or marks where it needs to do a little bit of work to completely fuse the rest of the way, but the majority of it is going to be almost invisible. You're not going to see that line anymore. Now, different sutures close at different rates. So some are a little bit more predictable than others on what age people are going to be whenever they start to obliterate. However, the same suture, maybe we're looking at the coronal suture, it's technically going to come down into your parietals, and maybe that spot right in the middle where all 3 of the sutures meet isn't fully obliterated, but the spots on your parietals might be obliterated. So don't assume that just because you're looking at the sagittal or the coronal, suture, the entire thing, that the entire thing is going to be the same scale score. We can also determine age through the pubic symphysis. This is on your os coxa or your pelvis. And what we're really looking for here is it is in a phase kind of scoring system. We also have it separated by male and female in more recent methodology, improved methodology for it, because there are some slight differences. And what we're really looking for is the condition of the pubic symphysis. So if it is a younger individual, that pubic symphysis is going to be very billowy. It's going to have a lot of texture, kind of like ripples going through it. It's also going to be a little bit rugged, so when you touch it, it's going to have a lot of texture. As we move and get older, you're going to start to lose that texture. And instead, you are going to see where it is starting to smooth out. There's a little bit of like a plate developing on top that is smoother, more uniform. It's going to lose a lot of that definition. By the time we get to older individuals, so phase 5, 4 or 5, you can see there's a pretty prominent lip that has kind of developed across the entire top of the pubic symphysis. It's very smooth. There's not a lot of other texture going on. Females have a little bit more texture. They tend to remain a little bit, having a little bit more texture than males do. By the time we get to 6, though, you don't need to be great at forensic anthropology to be able to tell that that individual is older, like pretty old, because you're actually going to see the pubic symphysis. It's going to be a very different shape where it's kind of almost like breaking down. You are also going to see that ridge that had developed in the previous iterations. It's going to be less pronounced because it has kind of taken over the entire thing. So it's not going to necessarily look like it is this ridge that's continuing to grow and smooth out the pubic symphysis. But you are going to see where it's a little bit misshapen. And also, if you do see a ridge around that at that point, it is very likely going to be the start of arthritis. Whenever you get arthritis in bones, it actually kind of builds up on the bone, and oftentimes it will kind of create that lipping effect. And it's a very interesting texture. It looks very interesting. It's pretty distinct. And it's also not uncommon. It's not totally uncommon even to see in younger individuals. In the pubic symphysis, it is, unless you've had an injury there that can kind of speed up that arthritic process. But generally, we do see arthritis in a lot of weight-bearing bones. So it's not unusual to see it in the pelvis, especially where your femur articulates, where the acetabulum is. It's also not uncommon to see it in the spine, especially in those lower lumbar vertebrae, because they are weight-bearing. So over time, and this is one of the problems with being bipedal, actually, over time, your spine is compressing in on itself because of the weight of holding yourself upright. If you've had an injury, or you're just getting significantly older, or maybe you're just not very active throughout your life, that is going to be a bigger issue for you because it is going to compress more. You're not going to be stretching it back out. And so you do tend to get a lot of arthritis in lower lumbar vertebrae, sometimes to the point that they will actually fuse together. All right, moving on to sex estimation. The first method that we're going to look at is using the skull. I think this is probably the most fun methodology to use for estimations. And it's also fairly simple, so you guys should be able to get some idea of what you're doing and feel pretty confident in it. Now again, these are going to be morphological traits. These are things that we can see. And we're going to start with the nuchal crest. Now this is actually the very back of your head. There's going to be a little bump, maybe a little bit of an overhang. Maybe some people might even have one that's a little bit pointy. That is the nuchal crest. Now, the best way to judge the nuchal crest whenever you actually have the physical remains is to take something flat and kind of hold it up against that dotted line that you see in the photo. And that will help you judge how even the nuchal crest actually is and ensure that you are not accidentally misrepresenting your results by having the skull moved one way or the other, the angle being a little bit off. The next thing we're going to look at is the mastoid processes. These sit right underneath where your ears are. Well, not right underneath. They are underneath and then slightly back, but essentially they're right underneath. We're also going to look at the supraorbital margin. This is your eye socket. What we do whenever we are looking at cases in person is we actually feel right there. And what we're feeling for is how sharp or how dull that margin is. Then you're going to look at the glabella. This is right between your eyebrows, that little bump there. And then finally, the mental eminence, which is on the jaw. And that's just the very tip of your chin. The best way to kind of double check yourself whenever you're looking at this is to actually put your fingers in the chin, in that divot that it makes, and then kind of judging and seeing how big the like upside down V shape that it makes is. Now, it is really important to note, no, it's very incredibly rare that any one person is going to be all ones or all fives. This is because we have a lot of variation. So the chances are that any remains that you look at are going to be a combination of them. Now, it's going to be very unusual if you're bouncing all across the board here. So maybe you've got a lot of ones and also a lot of fives. So it's like a pretty even mix. That would be very unusual. Typically, they're still going to stay around the same boat. So maybe you're going to have quite a few ones and twos or twos and threes, and then like 1 5, 1 4, that kind of thing. But when we're scoring these, we are scoring from 1 to 5, with 1 meaning that there is little to no projection. This means that it's very gracile. That's how we describe that. Anything that is closer to 1 is going to be more likely to be female. Anything that's closer to 5 is going to be very prominent. There's going to be a lot of projection. What we call this is that it is a very robust feature. So maybe they have a very robust mastoid process or mastoid processes, because you should be judging each one actually, because they can differ a little bit. But anything that is more robust is typically associated more with males. Now, you do have to be careful because, again, observer bias is a very real thing, and maybe you've just seen that the remains look very tiny and you just want to assume that it is a female. Well, you can't do that because oftentimes young boys, young men, are misidentified as female by just making those assumptions. Now, this is because young men that have not gone through puberty or have not finished puberty haven't had a chance for a lot of that testosterone to really kick in and then change the bone morphology to that robust nature that we typically associate with males. So you can end up misidentifying them as a female when it's actually a young man. On the other end of the spectrum, older women, like very older women, can sometimes be misidentified as males because as we age, we tend to get more arthritis. So you're getting more growth on bones that can make them look more robust. But also, it's just a natural part of aging that your bones start to kind of get more prominent until you are really, really old, like losing teeth, dentures, that kind of stuff. That you can typically tell, especially with the female, because you tend to lose body mass at those stages of life. Now, by this, I'm talking about people that are like 70s and older, or maybe somebody that has had like a very progressive age-related disease. So we do want to be careful here. Yeah, again, you really want to judge both sides whenever you do this. So the nupal crest, you've only got one of those. Mental eminence, you've only got one of those. The glabella, you've only got one of those. But your supraorbital margin and your mastoid processes, you have one on each side. So you really should be judging both. Because even within one individual, there is enough variation in growth and health and habits and other things that they may not be the same. You can also, of course, do sex estimation with the pelvis. And in many cases, if the full pelvis is available, this is actually preferred. This is because these are very distinct differences between male and females, if you're trained. So when you're looking at this, the overall pelvic shape, if it is very wide and short, that's going to indicate that it is female. If it's very long and narrow, that's indicative of male. We can also look at the coccyx, which if you remember from before break, that is what is attached to your sacrum. So it is what is essentially your tailbone. And in the images that you see there, it's that kind of V-shaped part in the middle of the pelvis. And then at the very end of that, you can see a little sharp kind of tail or like bell-shaped ending. That's your coccyx. In females, these are going to be nearly straight. Unless it is an older female, sometimes then you might have enough arthritis and other things that it kind of affects that, or if you have some kind of posture issues or scoliosis, it can affect it. But typically speaking, females are going to have a almost fully straight or a nearly straight coccyx. Males tend to have a coccyx that curves inward. They are allowed to have this because they don't have to push anything through it. If women had that, though, especially in our childbearing years, the baby would get stuck. And this does occasionally happen. That's part of the issue if like babies are coming out in breech because they aren't oriented correctly to get out without kind of raking themselves on the coccyx. That is also why a lot of women have issues with the fact that they want you to lay on your back in hospitals because it's not very conducive to helping to open up that pelvic space for an easier delivery. We're also going to look at the subpubic angle. In males, it's going to be very narrow. It's going to be kind of that like V shape, or I guess not really V, more like just triangle shaped. In females, it's going to be very wide. And on top of being very wide, it's going to have more of like a U or kind of a curve shape, a little bit more of like a parabola. And again, that has everything to do with the way that it has to work so that we can have children. You can also look at just one side of the pelvis, so just one of the os coxa. And when we do this, we're going to look at the sciatic notch. That is going to be this little kind of divot that you see there. I've got them labeled extra so that it's easier for you guys. And sciatic notches on a female are going to be very wide and open, just like our subpubic angle and everything else. So they're going to have more of that kind of U or just general kind of wide shape. Males, however, are going to have a very narrow shaped sciatic notch to the point that it's almost shaped like a candy cane. The top of that pelvis is going to curve inwards just a little bit and really give it that kind of hook shape. We can also look at the preauricular sulcus. We can look at this because males do not have a preauricular sulcus. Females do. Now, the preauricular sulcus is kind of this like U-shaped section on top of the os coxa there. and it will have a little bit of texture. It'll also kind of look like a raised rim almost. Now, occasionally men can kind of have that raised rim due to trauma on the bone or due to like other health issues. But even if they do have that raised rim, it's going to be very different from a preauricular sulcus, both in texture but also in how it looks. You can also tell sometimes if it is female with the os coxa, because around that preauricular sulcus, so maybe the preauricular sulcus is damaged, that isn't completely unusual, but sometimes there is a little bit of lipping right under that edge of the preauricular sulcus going around it. That lipping is only ever on women, and it's only ever on biological females. Now, this is because it is an indicator that somebody has been pregnant. It does not mean that somebody has necessarily given birth. Your body will do it whether you have a successful birth or not. Now, for a while, they used to kind of think that they could kind of like count the ridges, like the little divots there, the texture, and then determine how many children a woman had had in her lifetime. That's not very accurate. It's really not true. It just tells you that this person at some point was pregnant. And the reason that it happens is because whenever you are pregnant with a baby, babies need calcium. And so they will actually, especially if you don't get enough in your diet, they will leach it from the mother's bones. That's why a lot of women have issues with like osteoporosis after having a child and being pregnant. But it's also just something that happens in response to the strain that is put on the mother. I know that this is a long lecture. Bear with me. This is my favorite subject. But now that we are finished, we are going to go over your actual case reports. So you will see this on Blackboard. It is in the activities folder. And you're going to see this report that has a lot of bolded things on it. That is because I have designed these to be basically pre-filled. So all you really need to do is look at that bolded material and replace it with your information about the case that you are looking at. Do be sure that you are including the case number on your report. This case number C000 is not the case number that you are receiving. That is a placeholder just for this template. I do give you the case number in the actual materials that you are going to need to look at, so make sure you pay attention and replace that. But what you're going to find is you're going to have the date, you're going to have a identification summary, and that is where you're going to give me your estimated age range and your estimated sex without any other details. It's just the answer that you got. You're also going to give a very brief introduction. You can pretty well copy that exactly, just making sure to change the case number again. Then you're going to have your inventory. Now, on the instructions, it says that you need to determine which side each bone comes from, and you need to be specific about this and that. You don't. In fact, please don't. I have already put the individual that are in the photos in anatomical position, so you already know which side is which. Now, you do need to be careful though, because whenever you are siding remains, a lot of people want to side it based on what they see looking at it. However, that is a mirrored version of that individual. When you are doing siding, so whether a bone is from the left or the right side of the body, you need to have that bone relative to like how you are standing. So they need to be in anatomical position, which means they are standing or laying straight, and then their hands and arms are kind of out, and their legs are also spread a little bit. A lot of people will make the mistake of looking at a photo or looking at a table that has a set of remains on it, and they will use their right and left to try and decide. The problem is that individual is not oriented the same way that you are. They need to be oriented the same direction that you are facing, because we only really care about what is their left and right. However, you don't need to include left and right. It's already pretty much been done for you. You don't need to get super specific with your inventory either, so you don't need to say, here are how many bones that are in the hand, oops, excuse me, or in the feet. I'm tired. It's been a long day. What I would really just want you to do is say that there are hand bones available. So, you know, there's one hand or two hands, there's 1 foot or 2 feet. You don't have to get much more particular than that. You can include notes about the bones if you want to, so whether they are complete or if they look like they're damaged, the type of vertebrae that you see. You should actually include what type of vertebrae you see, whether it is cervical, lumbar, or sorry, cervical, thoracic, or lumbar if we're going in order. But again, this is a very basic inventory. I'm not super worried about it. I just want you guys to kind of get in the habit of recognizing these bones. The final part is going to be doing your estimation of sex and your estimation of age. So you've got your age here, and then your sex down at the bottom. You'll notice it's 1 paragraph for each one. It's really not, it's not that much. What this is for is anytime you have a case report, you need to be able to justify why you gave the answers that you did in your summary. Okay, so why do you think that they are this age range? Why do you think that they are female or male? Again, this has a lot of bolded stuff on it that you guys can take out and then just replace with what you have noticed from your case that you're looking at. But what is really important is that, one, you have to mention the type of method that you are using, so whose method it is, because there are a couple of different ones. Some are preferred over others. So for estimation of age, we are using the Mendel and Lovejoy 1985 method. For the estimation of sex, we are using Buekstra and Ubelecker 1994. I have not included information about which methods we're using for sex or age estimation from the ossicoxo or the pelvis, but that's because that's a little bit more advanced. I really want you guys to focus more on the skull. I think that is a better introductory lesson for you. Also, just in the effort of this not taking you guys forever to do, because I know that it's new and you're probably going to be second guessing yourselves a little bit or being a little bit confused about the methodology because you've never done it before. With your estimation of age, you do need to mention, like I said earlier, you need to mention which suture sections you are talking about and which ones were complete, which ones were partial more than 50% or partial less than 50%, and then which ones are open. You also need to include the scores that you get with the methodology. And then, of course, reiterate that the skeletal age range is estimated to be whatever you're estimating it as. That should be your very last sentence. For estimation of sex, you're just describing what you see. It's very simple. So you are going to decide, based off of what you've seen, whether your individual is more likely a female or more likely a male. Now, again, these are estimations, so we're never going to say this is this. If you have mostly ones, if that's what your average is, then you're going to say that this is a probable female. If you have pretty much all fives, then you are going to say that this is a probable male. If you are kind of one step removed either direction, you're going to say that it is a likely male or a likely female. And then if you are just getting threes for everything, that is very ambiguous. Also, it's very rare that you should ever be getting that many threes. You might get a couple, that's totally fine, but it shouldn't be your entire estimation. In fact, because I know this case, I know it should not be. But that is going to be more ambiguous, and in those instances where it is kind of all threes, whether that is because some pieces are damaged and so you can't really judge them correctly, or whether it's just like strangely ambiguous, then you are also going, you are going to mention that everything was neither, prominently robust or gracile. So you're going to tell me which of the traits of the glabella, the mastoid processes, the nuchal crest, which ones are gracile, so more feminine, and which ones are robust, or more masculine. You want to mention what you are actually observing, so you might also describe like your superior orbital margins and mention that they felt very sharp, which is indicative of female, or that they feel very blunt, or thick, which is indicative of male. At the very end, then you are going to then say that all of the observed traits that have been described above are indicative or are consistent with a skeletal estimation of that of a female or that of a male. It's really not too hard. When we look at our sex estimation, you were going to just judge every single trait, make a note of it, and then you're going to find the average. So you're going to add them all together. You're going to divide it by 5 or by 7 if you're doing each side for the orbital ridges and then the mastoid processes. You're going to add up all your scores. You're going to divide it by the total number of scores that you have, and you're going to find the average. If it's a 2, or, it's like a 2.1 or something, you know that this person is likely a female. Not that hard. Age estimation does trip people up more. Now, I have examples, and they'll probably be easier to see on Blackboard, of what the suture should look like for each score. This diagram right here tells you how to find your vault and your lateral anterior scores. So they're all labeled, these different points in the skull. What you're going to do is you're going to look at the sutures at that specific point, and you are going to go ahead and judge it. How closed is it? That 0 through 3 kind of scale that we had going. Then you're going to notice there is this box at the very bottom, this table. This is what you're going to use to determine your age range. So once you have found all of your scores, you are going to add them up. Then you're going to look at your table. Now, this is separated. They are actually 2 tables. This one is your vault scores. This side is your lateral anterior scores. You can find what that means by looking at our diagram here. It tells you exactly which numbers on the skull correlate to what type of scores. You're going to add all of those up, and you're going to line it. So for your vault scores, you're going to add up your numbers for 1 through 7. Whatever you end up with, you're going to find on the scale. You're going to follow it over to the mean age. That's going to be your average age that we can expect this individual to be. However, remember I mentioned we don't want to give an exact age. So you're going to see when you move right past it, this SD. I know everything is kind of inverted. I'm sorry. Microsoft doesn't want to let me show you my Blackboard right now, so this is what we got. Anyway, this SD that you see stands for standard deviation. To get your range, you are going to add and subtract this number from the mean age. So you're going to start with, let's see, let's say the person scored between 12 and 15 for their composite score. When we added everything up, we're going to follow it over, and we're going to see that it's 45.2. This is in years, by the way. When we follow it back over, we're going to see that the standard deviation is 12.6. To find our range, we're going to take that 45.2 and subtract 12.6 from it. This is going to give us the lowest part of our range. Once we are done, we're going to take that 45.2 again, and we're going to add the 12.6 to it. That's going to give us the highest part of our range, and that will give you your age range that you're looking for. Now, don't forget that we also need to do the lateral anterior scores. They're slightly less accurate than the vault scores, but it's good to do both because it can give you a bigger picture of what's going on with this individual. So you're going to follow the same exact process, and you should get an age range that is similar or somewhat overlapping. From there, it is your job to decide which one you think is probably more accurate. You can also shove them kind of together, so maybe use the, maybe the highest range for your vault system is actually your lowest range for your lateral anterior system. Go ahead and put them together. You get to decide what the range is and how big you are willing to go with it. Now, you don't want to go, oh, this person is anywhere from 18 to 67, because that's not helpful. That's too big of a range. But generally, anything that's within 20, 30 years is okay, especially in the middle ages kind of thing. So if you want to say that somebody is maybe 25 through 45, that's fine. You shouldn't be giving that huge of a range if the person that you're looking at is like really, really old, because they should have indicators that they are an older individual. So you might instead say that they are anywhere from like 60 or 65. It kind of depends on what your what you get from that table. You might say that they're like anywhere from 65 to 80. Now, the chances are, because the individuals that we have in our lab have all been donated to science by very lovely people, very kind of them to allow us to use their remains in this way. However, there is not a lot of variation. Most of the remains that have been donated to our collection or that we have on loan is going to be old white people. And I'm not talking just like older, like middle-aged white people. The youngest person in our collection is only 45 years old. However, it's the only person that we have that is that young. The average age of most of the remains in our collection are 75 to even 90. Because of this, you're not going to get a lot of variation on what you're looking at. You might have some things that are kind of covered up by like arthritis or other injuries. And you might even end up with a composite score that goes past what this table can offer you. If it goes past, that's totally fine. I expect that to happen. What you're going to do then is you're going to find your range from that one right above it, the last full line. And you're going to mention that range in your report as a kind of qualifier. So you are going to mention that this age, or that the individual is at least in this age range, but that they are likely older. Now, you guys don't need to get very specific with how much older you think they are, because you don't have the experience studying an entire body to kind of pick up on those extra context clues. But you do need to mention that, you know, if you estimate that this individual is older, then you need to mention that last full line on your chart, because otherwise you have no frame of reference. You have nothing to create that basic or that base age range from. Now, one last thing, I swear, before I go, since I've been holding you guys up for an hour and a half now. As soon as you get your contracts submitted, your ethics contracts, you should have access to the material now. You can access freely all of this material, as well as the instructions for how to fill it out. They go into a little bit more detail. I don't think you guys should need that since we kind of ran through it together. But just in case, it is there. But until you have that ethics contract submitted, you will not be able to open the actual photos and materials that you need to complete this lab. So if you haven't submitted that, please make sure you do. And then I want to reiterate one more time, please do not share, save, show anybody these photos. It is not appropriate to do so. You will be breaking ethical code by doing so. And it is something that I will have to report to the university, and it will have fairly serious consequences. So just be respectful. I'm glad that we get to do this lab because I do think it's a fun one, and I think it's something that most people never get to do in their lives. So don't make me regret it. Don't stress too much about this. Like I said, you don't need to have perfect answers. What I'm mostly concerned about is that you have your inventory filled out and that you have some good logic to support your estimations. If you have any questions, of course, let me know.